This is the practice test for chapter 3. So hopefully you've tried all these problems on your own already, and I'm going to work these out. Alright, here's the transformation, and the transformations are usually in the form like this. And if there is a minus something here, that's going to be going to the right. If it's plus, it will be going to the left. And this value out here, if it's outside of the parentheses, it's going to be a up and down displacement or movement. So this is a shift, horizontal shift, vertical shift. And if there was a sign in here, this would be a negative sign in here. That would be a reflection on the y-axis. And negative sign out here would be a reflection on the x-axis. Okay. Let me write that in here for you. Reflection on x-axis. And this one in here would be a reflection on the y-axis. This is your horizontal shift. And this is your vertical shift. So in this problem, we have a -3, so this is a horizontal shift. So it will be 3 to the right. Okay, give the domain. The domain are the x values of this graph, and exponential functions look like this. They hug the x-axis and they come up and they go up like this, and it crosses at 1. Okay, so exponentials are like this. So the domain for this graph would be, it can go anywhere to the left on the x-axis, and it can go anywhere to the right on the x-axis. So the domain would be negative infinity to positive infinity. Okay. While we're talking about the domain, let's also talk about the domain of a log function. The log function, you have a graph that will look like the mirror image of this on the diagonal. So it's going to come around and do this. So now the domain for the log function, it can only go up to the 0, and it has to stop because there's no more graph there. But it can go to the right forever. So the domain for a log function, log of x, then this will be from 0 to positive infinity. And this is for an exponential function, or of any base, either this, or even anything like that. Okay? And this would be a log function of any base also. Number 3. Give the domain of the function. The domain of the function, like I said, would be from 0 to infinity for this, but this has been shifted 2 different ways. This has been flipped. Well, it's going to be flipped, but let's see. We're going to shift it 2 to the right, and we're also going to flip it on the y-axis and the x-axis. So if we do that, first it would have been like that, but now instead of crossing at the 1, it's going to cross at the 3 because it's going 2 to the right from here. Add 2 more. So it's going to actually cross here. And there was a vertical asymptote on this one on the y-axis, and we shift that vertical asymptote 2 to the right. We should get asymptote here, and the graph will actually look like this. Okay, but we have to flip it on the x-axis, and we have to flip it on the y-axis. Now, what is my domain? This is kind of a tricky one. Now my domain will be from negative infinity all the way up to positive 2. Alright, the asymptote for this function will be, let's see, we're going to shift it to the right by 2, so it was right there, so now it's going to be here, and now the asymptote is going to be, the graph is going to be like that. So the vertical asymptote was at the y-axis, now it got shifted to the right. So now the vertical asymptote is going to be at x is equal to 2, and there is no horizontal asymptote because it goes on forever down and forever up. Okay? Alright. Okay, number 5. Okay, solve for x. Now you have 3 is equal to 9x. In order to get that exponent out of the exponent position, I'm going to have to take some kind of log on both sides, and this will be natural log of 3 is equal to natural log of 9, and that x comes in the front. In order to finish this, I'm going to divide both sides by log of 9, and I get x is equal to the log of 3 over the log of 9 because yes, this is cancelled. And using my calculator to finish this off, I get, let's see, natural log of 3 divided by natural log of 9. I get 1/2. Now, if you think about it, this would be 3 is equal to 9 to the 1/2. This is the square root, so 3 is equal to the square root of 9, which is good. Okay, now number 6. Simplify. You have 16 to the negative 12 over 8. Now 12 over 8 can be reduced by 4, so this will be 3 over 2. And first, I'm going to use up that negative sign and flip it, because the negative means the reciprocal. Then I'm going to use up the denominator. Right here, that's a half, right? Just like half over here. This will be the square root of 16 would have been 4. And now 4 cubed is 4 times 4 times 4, which is 64. Write an expression that is equivalent to log base 5 of 4 using the change of base rule. So you can use any log. I'm going to use a common log. and that'll be 4 over 5. As long as these two numbers are the same down here, you could write that as a, how about 3, okay? And that would also work. Anytime that the bases are the same in here, or you can even use natural log, because that would just be a log base e. Alright, any of these would be okay. Alright, number 8. Evaluate. Well, this you're just going to do on your calculator. Alright, so I'm just going to do this on my calculator. See here, we can get rid of that. I was working on some stats right there. Alright, so this is going to be 7 caret negative radical 3. Okay, make sure you know how to use your calculator when you're doing this, and actually put those numbers in and see if you actually get the numbers I'm getting here. And 3 decimal places, and the 7 makes that 3 of 4. Okay, and then, oh, that's supposed to be a pi. Alright, so this is we're going to put that in my calculator, and then we go 5 to the pi, which is 156.993, because that 5 makes that a 2, a 3. And now graph this. And in order to graph this, it's quite simple. We're just going to make a little t-table. X and f of x, or y. And then we're going to get some numbers here. And I know that exponential functions will go like this. So I'm going to put in like, oh, let's say negative 3, negative 2, negative 1, 0, 1, and 2. That should probably take care of it. 2 to the 0 power, anything to the 0 power is 1, and 1 minus 1 is 0. 2 to the 1 power is 2 minus 1 is 1. 2 to the second power is 4 minus 1 is 3. Now 2 to the negative 1 is 1/2, because it's a reciprocal. This negative sign means to take the reciprocal. So we have a half minus 1, which is negative 1/2. Then we have 2 to the negative 2, which means we're going to take the reciprocal, and that's 1/4. Well, 1/4 minus 1 is a negative 3/4. And then taking the negative 3, 2 to the negative 3 is equal to the reciprocal of 2 to the third, which is equal to 1/8. Okay, and then minus the 1 will give you a negative 7/8. Alright, so putting these numbers in, I'm going to get, let's see, 0, 1, 1, 2, 3, and then negative 1, negative 1/2, and then negative 2, negative 3/4, negative 3, negative 7/8. So now I can go ahead and put my line in. Let's use a green mark here. Okay, that's not that bad. Alright, number 11. 1.234 times 10 to the negative 4, moving the decimal 1, 2, 3, 4 times. So that is really going to equal 0.000123. Okay, all right. Number 11. Okay, number 11. The population of an endangered animal species is given by the function 500 times 0.9 to the t, where 500 is the number of animals currently in the population, and t is the time in years. The population is decreasing at a rate of 10%. What is the estimated number of animals in this population? Well, here is the initial number here. That's what this number is. This is actually PERT, and this is going to be decreasing by 10%. So that's what the 90 is. It's going to be 90% of it that left every year. So to give you the full function, all you have to do is plug in the number. So the number of animals is f of x is going to be equal to 500 times 0.90 to the 15th power. Okay, doing that on my calculator, I get 102.946. So what is the estimated number of animals after 15 years? It looks like about 103 animals left after 15 years, starting with 500. So make sure the numbers make sense. Numbers that each year is going down by 10%. So after 10 years, there are only 103 animals left. So that makes sense. All right. If $500 is invested in a long-term trust fund with an interest rate of 5% compounded continuously should remind you that it's going to be a PERT problem. What is the amount of money in the account after 15 years? So what is the amount after 15? You're solving for A is what you want to know, and P is the initial amount, and R is equal to 0.05. Move the decimal over 2 times because of the percent sign. And then T is equal to 15 years. Okay, putting this all together, A is equal to 500 times e to the 0.05 times 15. Okay, so doing this on my calculator, I get 1,058.50. Okay, number 14. Evaluate. Just use your calculator. Log of 4, common base, which is 0.602 rounded. Find the exponential form for this. Remember, logs always equal the exponent, and this is your base. So here's my base. This is my exponent on that base, and that 4 is what's left over. Okay. evaluate this. So evaluate means to use your calculator, but we don't really need to because these cancel each other, so that's equals to 6x. Evaluate natural log of 72 on my calculator. I get rounded 4.277. Number 18. Okay, log base 4, so I'm going to do a change of base. And on my calculator now, log of 143 over the log of 4 gives me approximately 3.5799, so it'll be not 80. Okay, this expand. When you have a division, it's going to be a subtraction. Multiplication is addition. So, okay, first we're going to have two pieces here. We're going to have log base 7 and a log base 7. This one is going to be x to the 1/4, so x to the 1/4, the exponent goes in the front. It's going to be minus y to the 3rd. Condensing, going the other way. Now we have log base 6. We're only allowed to use the log symbol one time when we're condensing. So now we have x to the 3rd over, because it's a negative, so this will be x minus 2 to the 2, and then since this is negative, that goes in the denominator also, times 4x, like that. Okay, number 21. Solving this, I'm going to add log 18 to both sides. Take the anti-log. So x is equal to 18. Solve for x. So I'm going to take the anti-log of both sides using the base here. So now I get x plus 3 is equal to 4 squared. Subtract the 3. And I get x is equal to 13. Solving this one, subtract the 12 from both sides. I get 5e to the 0.03x is equal to 24. Divide both sides by 5. So e to the 0.03x is equal to 24 over 5. Take the natural log of both sides to cancel my e. So 0.03x is equal to the natural log of 24 over 5. Divide both sides by 0.03. And then using my calculator to finish this off, I'm going to have natural log of 24 over 5, all of that over 0.03, and I get approximately 52.287. Find the time required to for an investment of $1,200 to double. There, I taught this shortcut before, but if you don't remember, then that's fine because it's compounded continuously. You know this is a PERT problem. And I always like to start off by writing out all my stuff here. This is the amount invested, so that's the beginning amount, that's P. My rate is 0.12, and the T is what we're trying to find. Now it seems like we don't have enough information, but we do. We want to double our money. So if we start out with $1,200, we double it. That means A has to equal $2,400. We want to double our money. So now it's going to be 2,400, that's A, is equal to P, 1,200, times E to the 0.12 T. Divide both sides by 1,200. There's that magic 2 that I showed you in the shortcut. Then take the natural log of both sides to get rid of my E. So now I have the natural log of 2 is equal to 0.12 T. Divide both sides by 0.12. And then T is approximately 5.77 years. 5.78, or actually we're talking about years, let's just do 5.8 years. Alright, last one. Okay, number of bacteria present in a culture is given by this equation. When T is time in minutes, find the time required, the nearest half minute, to have 8,400 bacteria. So my 8,400 is B now. That's equal to this, the 0.3 T. We're solving for T. Divide by 100. 84 is equal to E to the 0.3 T, natural log of both sides, and we get natural log of 84 is equal to 0.3 T, divide by 0.3, and then we get T is equal to 14.7693, but it says round to the nearest half minute. So if we're rounding half minute, this is closer to 15 than it is to 14 and a half. So I'm going to round that to 15 minutes. That's it.